So, you've been doing a deep dive into all this AI stuff, huh? Specifically language models.
Yeah, it's been pretty fascinating actually.
I see you've got a whole stack of research papers there. Looks like you've been digging into small language models,
Yeah.
SLMs.
Right.
It's interesting, how gaining traction even with these massive LLMs like ChatGPT grabbing all the headlines.
It really is like everyone got so caught up in the bigger is better hype with AI for a while there.
Right.
But now it's like there's this realization that SLMs have their own unique strengths.
Okay, so let's get this straight. We're not just talking about ChatGPT Mini here.
Right.
SLMs are a different thing,
Exactly.
their own distinct category.
Defining an SLM, though, it's not as straightforward as you might think.
Really?
It's less about a strict number of parameters and more about what they can do.
Oh, okay.
The source I was looking at suggests that we should focus on their ability to handle specialized tasks.
Okay.
And also their suitability for situations where resources are limited.
That makes sense.
Yeah.
So it's like, instead of a Swiss Army knife, it's more like a scalpel.
Ooh, that's a great analogy.
You wouldn't use a Swiss Army knife for brain surgery.
Right, exactly. Like,
Yeah.
think about trying to run a complex AI model on your phone or a medical device or something.
Oh, yeah.
You can't just cram a model with billions of parameters onto something like that.
Right, right. And I bet there's some privacy advantages there, too.
Absolutely. With SLMs, you can process data locally
Okay.
instead of sending it off to some giant, cloud-based model.
Yeah, yeah.
That's a huge win for things like healthcare, where data sensitivity is super important.
Absolutely. So how do you even create an SLM? Do you, like, shrink down one of those massive models?
You can.
Okay.
It's a bit like bonsai for AI.
Bonsai for AI. Okay.
It's called pruning. Essentially, you're trimming away the less important connections in a large model
Okay.
to make it smaller.
Pruning the AI tree. I like that.
Yeah.
What other techniques are there?
There's another one called knowledge distillation. Imagine an experienced chef teaching a young apprentice. The apprentice learns by observing and mimicking the chef's techniques, right?
Yeah.
Knowledge distillation works kind of the same way. You train a smaller model to mimic the behavior of a larger, more complex one.
Okay, I get it. Now, what about this quantization? That one sounds pretty technical.
It can get a bit deep,
Yeah.
but think of it like this. Instead of using super precise numbers to represent the model's knowledge, we use slightly less precise ones.
Okay.
And this saves on storage and processing power without sacrificing too much performance.
So you can create an SLM by essentially bonsaiing a larger model.
Yeah.
Or you can build one from scratch.
Right. That's a different approach altogether. It starts with carefully selecting and cleaning the data used to train the model.
Yeah.
And you also use these techniques like BPE and word piece.
Hold on. BPE and word piece. Those ring a bell.
Mm-hmm.
They're ways of breaking down words,
Yeah.
right? Like from when I was reading about NLP.
Yeah, exactly. It's like taking apart a complex Lego structure and rebuilding something smaller and more efficient with the same pieces.
Gotcha.
BPE and word piece, they let the model handle a wider range of vocabulary with fewer parameters.
It's all about efficiency, huh?
Yeah.
Seems like researchers are always finding ways to make SLMs even more powerful, too.
Oh,
What are
absolutely.
they up to these days?
Well, one that's really interesting is called instruction tuning.
Instruction tuning. Okay.
Imagine giving the model a very specific set of instructions, like a crash course in a particular subject.
Yeah.
This fine-tunes the SLM to excel at that specific task.
So you can have an SLM that's a whiz at medical diagnosis or legal analysis or even writing code.
Exactly. There's this fascinating example in the research, the self-reflective instruction annotation framework used in this model called SciGLM.
Okay.
And it actually uses a larger LLM to generate step-by-step reasoning for scientific problems.
Wow.
And then it uses that to train the smaller SciGLM to do the same thing.
So it's like the model is analyzing its own thought process.
Yeah, it's pretty
The
wonderful.
applications for this stuff, it seems limitless.
It really does. They're popping up everywhere.
Yeah.
We're seeing them used in question answering systems, especially in specialized fields.
Hmm.
Coding assistants, recommendation systems, and even controlling devices.
Controlling devices. You mean like my phone?
Yep. Think about using voice commands to control your smart home, or having an SLM automate tasks on your phone based on your current context.
So it's like having a tiny, super intelligent assistant in your pocket.
Exactly.
That's incredible. So it sounds like SLMs aren't just about replacing those giant LLMs.
Right.
It's more like working with them, right?
You're absolutely right. SLMs and LLMs can actually work together, kind of like a dynamic duo, to improve reliability and safety, which is a big deal with powerful AI systems.
How does that work?
Imagine an SLM acting as a fact checker for a larger LLM, catching any potential errors or biases. They can also help LLMs access and process external knowledge more efficiently.
Right, right. Which is key for complex tasks.
Yeah,
Now,
exactly.
it's more of a collaboration. Each model kind of plays to its strengths. I
Exactly.
like it. Now, this whole thing with SLMs running on phones and devices, it makes me think about practical limitations.
Oh, for sure.
Yeah.
That's a crucial point. Even though SLMs are designed to be efficient, optimizing for memory and runtime is still super important, especially on devices with limited resources.
So what kind of techniques are we talking about here?
Well, we've already touched on quantization,
Right.
but there's also something called KV cache compression.
KV cache compression.
It's a way of cleverly storing and accessing the information the model needs without hogging too much space or time.
So it's all about squeezing every ounce of performance out of the hardware.
Precisely. It's like fitting a whole library into a tiny travel bag. And it's not just about the model itself, it's also about the data it's processing. Techniques like MOE expert caching can help manage the flow of information so the model can quickly access what it needs.
MOE expert caching. Now that sounds like a whole other deep dive waiting to happen.
It definitely is. There's a lot to explore there.
But even with all this optimization, it seems like there's always going to be that tension between what we want these models to do and what our devices can realistically handle, right?
Absolutely. It's a constant challenge, but it's also what drives innovation. The contrast between theoretical capabilities and real-world limitations is a fascinating space to explore.
So we've got these amazing SLMs that are efficient, customizable, and they can run on all sorts of devices.
Mhm.
What does all this mean for the future of AI?
Well, it's clear that SLMs are poised to become an even bigger part of our lives.
Yeah,
We can expect them to be integrated into more and more applications, making things easier, more efficient, and even more personalized.
that's pretty exciting.
Okay.
Sounds like we're on the verge of a real AI revolution.
It definitely feels that way. But, as with any powerful technology, there are questions we need to consider.
Like what? Give us a sneak peek of what's to come in the next part of our deep dive.
Well, as SLMs become, more integrated into our lives, one question that comes up is how do we ensure they're used responsibly?
That's a great point. It's like we're giving these SLMs more and more responsibilities,
Yeah.
so we need to make sure they're up to the task, right?
Exactly, yeah. And actually, one of the research papers you shared dives into this whole responsibility thing by focusing on how SLMs are being used for mobile device control.
Oh, yeah, yeah. That was a fascinating paper. Sounds super futuristic.
It really is. The paper talks about this model called Mobile Agent,
Uh-huh.
and it uses a combination of instructions and something called Standard Operating Procedures, or SOPs, to enhance the performance of SLMs in controlling a mobile device.
SOPs, like a set of step-by-step instructions.
Precisely. Imagine you want to book a dental appointment through an app on your phone.
Okay.
The SOP would guide the SLM on how to open the app, navigate to the booking section, select a date and time, and confirm the appointment.
So the SLM is basically acting like a personal assistant then.
Exactly. And it's not just limited to simple tasks either.
Really?
Mobile Agent has actually been shown to perform some pretty complex actions, like making calls, sending messages, and even controlling smart home devices, all through voice command.
That's incredible. It's like straight out of a sci-fi movie or something.
Right.
What about privacy concerns, though?
Oh, yeah.
If these SLMs are controlling our devices, wouldn't they have access to a lot of our sensitive information?
That's a totally valid concern, but the researchers behind Mobile Agent have been very careful about addressing that. They've designed the model to only access the information that's absolutely necessary to complete a specific task.
So if I'm booking a dental appointment, the SLM would only see my calendar and the dentist's contact info, not like my whole photo library.
Exactly. Plus, all of the data is processed locally on the device, not sent off to some remote server. It's all about building privacy into the design from the ground up.
That's reassuring. It seems like there's a lot of thought going into the practical and responsible side of using SLMs for this mobile device control. Now, what about other areas where SLMs are making a big impact?
Well, another paper you shared dives into the world of coding. LLMs, like ChatGPT, they've been making headlines for their coding prowess, but SLMs are also carving out a niche for themselves in that world.
I'm all ears. especially since I dabble in coding myself.
One of the interesting things about SLMs is that they're particularly well suited for coding assistance in resource-constrained environments.
You mean like when developers are working on embedded systems or mobile apps where they might not have access to powerful cloud-based LLMs?
Exactly. Think of it like having a coding buddy right there on your device, offering real-time suggestions and catching errors, even if you don't have the best internet connection.
That would be a game changer for a lot of developers out there. What kind of SLMs are they using for this kind of coding assistance?
The paper you shared highlights a model called Phi 3.5 Mini. It's specifically designed for coding tasks and can hold its own against much larger LLMs.
Phi 3.5 Mini, is that related to that Phi model that was in the news recently, the one that could actually reason about code?
That's the one. Phi 3.5 Mini is like a smaller, more efficient version of that original Phi model. It's been fine-tuned and optimized to run smoothly on devices with limited resources while still retaining its ability to, understand and work with code.
So not only can these SLMs control our devices, they can help us build the software that runs on them too. It's amazing how versatile they are. But how are these models actually deployed in practice? Are they just standalone apps, or are they being integrated into existing systems?
It's kind of a mix of both, actually. Some SLMs are packaged as standalone apps, like those mobile device control examples we just talked about.
Right.
But we're also seeing them being embedded into, operating systems, web browsers, and even cloud platforms.
So SLMs could be running behind the scenes, powering all sorts of applications without us even realizing it.
Exactly. Like imagine an SLM integrated into your phone's operating system.
Okay.
It could personalize your notifications, optimize your battery life, or even predict your needs based on your usage patterns.
It's like having this tiny AI genius quietly working in the background, making everything run smoother.
Yeah.
Pretty mind-blowing to think about. But with all this focus on SLMs, I'm curious, what happens to the big LLMs?
Right.
Are they just going to fade away as SLMs become more powerful?
Not at all. LLMs still have a vital role to play in the AI landscape. They're the heavy hitters, capable of handling complex tasks that require vast amounts of knowledge and computational power.
So it's not a case of one replacing the other. It's more like finding the right tool for the job.
Precisely. LLMs are like the master architects designing the grand plans, while SLMs are the skilled craftspeople, meticulously bringing those plans to life in specific ways.
It's like a well-coordinated team, with each member bringing their own expertise to the table.
Exactly. And we're even seeing collaborations between LLMs and SLMs. For example, SLMs can be used to double-check the output of LLMs, ensuring accuracy, or to help LLMs access external information more efficiently.
So it's not a competition, it's more like a synergy. Each type of model complements the other.
Right.
This whole conversation has really highlighted the importance of data quality in training these models.
You're absolutely right. Data quality is like paramount. It's the foundation on which these models are built. If you train an SLM on biased or inaccurate data, it will reflect those biases in its output.
So it's not just about having tons of data, it's about having the right data.
Exactly. And it's not just about the content of the data, but also the format and structure. SLMs need to be trained on data that's been carefully cleaned, organized, and annotated so they can learn effectively.
It sounds like a lot of effort goes into preparing data for these models.
Oh, it definitely does. It's an ongoing challenge, especially as the volume of data keeps growing, exponentially.
So what are researchers doing? Like, how are they making sure this data is top-notch?
Well, one really interesting approach is to actually use existing LLMs to help generate high-quality training data for SLMs.
Wait, so the big LLMs can actually help train the smaller SLMs.
That's right. For example, an LLM can be used to rephrase existing text, create new examples, or even generate synthetic data that's tailored for a specific task.
That's pretty ingenious. It seems like there's a real sense of collaboration and shared learning happening in the AI world. It's not just about individual models, it's about building a whole ecosystem of AI that can work together.
That's a great observation. And as we move into the final part of our deep dive, we can explore some of the exciting new directions SLM research is taking and how these models are poised to shape the future of AI.
Okay, so we've talked about what SLMs are and the different ways they're being used, even how they can team up with those giant LLMs.
Right.
But there was that one paper that proposed a new way of thinking about SLMs. It challenged the traditional definition, right?
Yeah, it seems like the old way of defining SLMs, just based on how many parameters they have, it's getting kind of outdated.
Especially with all these new techniques for making them smaller and more efficient.
Right. Like, we're seeing models with relatively few parameters doing some pretty amazing things these days.
So it's not just about size anymore, it's about what they can actually do.
Exactly. The authors of that paper, they suggest that we should focus on two main things.
Okay.
First, the ability to handle those specialized tasks.
So instead of being a jack of all trades, it's more like being an expert in one particular field.
Yeah, exactly. And second, how well suited they are for those environments where resources are limited.
You mean like, can they actually run on devices that don't have a lot of processing power or memory or battery life? It's a much more practical definition. I like it.
Less about the raw specs and more about real-world usefulness.
Right, exactly.
It kind of reflects how the whole field of SLMs is maturing, you know?
Yeah.
We're moving beyond just proving that they work in theory, and we're starting to actually use them to solve real problems.
It makes me wonder if we're going to start seeing a whole taxonomy of these SLMs emerge.
Oh, yeah.
Each one tailored for a specific niche, like maybe SLMs for medical diagnosis, SLMs for legal analysis, SLMs for financial forecasting.
Definitely a possibility. It's almost like the evolution of species.
Right. Each SLM adapting to its own particular environment.
Exactly. And just like in nature, we're going to see a lot of diversity and specialization as this technology keeps evolving. Now, what about you? What are some of the trends you're seeing in SLM research? Where are those exciting breakthroughs happening?
Well, one area that's really hot right now is the development of new model architectures.
Okay.
I've talked a lot about transformers. Those have been the go-to for language models for a while. But researchers are starting to explore some alternative approaches that could be even more efficient, or maybe even more capable.
Like what?
Well, for example, state space models, or SSMs.
SSMs? Okay.
They offer a different way of representing and processing sequential data, which is basically what language is, right?
Yeah.
So instead of relying on that attention mechanism that's at the heart of transformers, SSMs use a different kind of math framework to model the relationships between words.
Interesting.
And some early research suggests that SSMs could be really good at tasks that require understanding those long-range dependencies.
Long-range dependencies.
Yeah, like connections between words that are far apart in a sentence.
Ah,
That could be huge for things like text summarization or question answering, where you need to understand the context of a whole document.
right. That makes sense.
Another area where there's a lot of potential for innovation is data efficiency.
Mm-hmm.
We talked about how important it is to have the right kind of data, but there's also the challenge of just having enough data to train these models properly.
Especially for those specialized tasks where there might not be a lot of labeled data out there.
Exactly.
Researchers are looking into things like few-shot learning, where you can train SLMs on a very small amount of data, and transfer learning, where you take a model that's already been trained on a massive data set and fine-tune it for a more specific task.
So it's like taking this general purpose AI and giving it a crash course in like a very specific field.
Exactly. These techniques are going to be key to developing those SLMs for all those niche applications where huge labeled data sets just don't exist.
It's all about making the most of what we have, finding clever ways to adapt to these new challenges.
Yeah, well said.
This whole deep dive has been really eye-opening.
Yeah.
It feels like we've only just started to explore what SLMs can really do.
We definitely covered a lot of ground.
I'm walking away feeling really excited about the future of AI, especially with the SLMs, because it seems like they have the potential to make all this amazing technology accessible to everybody.
I completely agree.
It's a really exciting time to be working in this field.
It is. I can't wait to see what the future holds for SLMs.
Well, thanks for joining me for this deep dive into the world of small language models. It's been a fascinating journey.
The pleasure was all mine.